So coming to the mole concept, so if you'll notice it in our daily life, basically if you'll see in our day-to-day life, so we are used to count so many different kind of objects. So you will ask even money, we will count, we'll count the things, we'll count the books and a lot of things like the pens, pencils, even we can take fruits, banana. If we'll buy 1 kg apple, we'll say how many, 6 apples came or 7 apples came. Like that, we'll just simply counting them because they are if we'll take like usually they are large in size and they're required in a limited number. Suppose if we'll go to a banana shop, if we'll buy banana, he'll ask suppose 1 dozen. He'll say that either 12 bananas are there or not. We'll count like that because they're looks very bigger to us as well as they're required in a limited number for us so that we will count it. So now, suppose if I'll ask you to enter into a banana field, agriculture land, which is around 5 acres or 6 acres, and I'll ask you to count the bananas all. Is it possible to count? Yes, please. Of course, it is possible, but it is a very time-taking process. Yes or no? And we will never show even interest. We will never show interest because it is very, very large quantity. So when it is a limited number in our day-to-day life, whatever it is, if we'll take fruits, if we'll take any kind of notebooks or pens or pencils, everything, if it is in a limited number, we will simply counting them by 1, 2, 3, 4 like that. But have you ever thought, like as I told, like if you enter into the agriculture field and I'll ask them to count the number of rice grains are present, understanding in each grain, each stalk, like bananas or something, if I'll ask, why can't we find this in numbers? If I'll ask, suppose I have given you one big packet of rice and I'll ask you to count them. Why can't we count them? Anyone? Yes, please. What is the reason? Why can't we count rice? If we'll take banana, if we'll take apples, if we'll take pencils and all, we are counting. If it comes to the rice, why can't we count? All of you tell me. We cannot count. Why? Nobody will answer. Because what is the size of the rice? All of you, what is the reason? They are
It is very small.
Understanding. They are small, so small in size. Understanding. So small in size. So it will take so less time or more time to count. That is what my question. It will take how much time? It will take a lot of time. Understanding or more time to count them. So that is why. Suppose if I'll ask banana, suppose Mitakshri is having bananas and as well as rice. Now, if somebody will go and ask banana, she will count and she can give. But somebody will ask rice. Suppose Harish and went and asked, give me 1,000 rice grains. Is it possible to give, Mitakshri? Yes. So it will be a very time-taking process and we cannot count them easily. That is why simply what you will do, you will wait and you will give them. Is it yes or no? You will weigh them and give, like 1 kg, half kg. Yes or no, Harish? Please respond.
Yes, sir.
That is what you have to remember. So when it is in small in size, instead of counting, we are going with the weighing. Similarly, in banks also, if we'll take, money is counting by not humans. Suppose if we'll take in our home, maybe 10,000 or 20,000 or maybe 1 lakh or 10 lakhs. So we people can count by sitting in the hands. But if we'll go to the bank is having what? Crores of money dealings per day. So what they will do, guys? They will use a mission. What is that they will use mission? That mission is called as what? Weighing the coins. Have you noticed it? So now if you notice, in our home maybe having 100 coins or 200 coins so that you can easily count. But if you go to the banks is having tons of coins, means lakhs of coins are there. So bank people cannot sit and measure. So what they will do means they will measure the mass of one coin. Do you understand, everybody? Mass of one coin, for example, all 1 rupee coins are there, all 2 rupee coins are there. They'll measure the mass of one coin, and now they will put everything into the bag and they will measure directly by weighing the mass of coins, not the notes. Remember, I'm saying only coins. Okay. So entire mass they will measure by putting the weighing machine. Suppose, as we know, for example, one rupee coin, one coin is coming, like for example, in 10 grams. Means 100 grams is equals to how many 1 rupees, guys? Anybody? 10 rupees. Suppose 1000 grams equals to how many 1 rupees are in? Now 100 rupees.
100.
Yes or no? Like that they will measure. Because why they are using weighing machine instead of counting in banks? Everybody? What is the reason?
Reduces the time taken.
Because large number of coins is present with the different denominations. One is 2 rupees coins, 3 rupees coins, 5 rupees coins, sorry, no 3 rupees. 1 rupee, 2 rupee, 5 rupees, nowadays 10 rupees also there. So that large number of coins of different denominations, it is too tough to count such a large number. It is very difficult task and it is also a time-taking process. So that is why, to make it easy, coins are weighed instead of counting. So simply they will be weighed instead of counting and they will make the total denomination. So that is why the staff of bank knows that a fixed mass of a particular coin will have a fixed number of coins. So they have to know the mass of the bank employees knows mass of 1 rupee coin, mass of 2 rupees coin, mass of 5 rupees coin. Then based upon that, they will fix a number of coins and they will measure the weight and they will come to know the total denomination. So they can relate the mass of coins with something. What is that, guys? Number of coins. Here you can see here, as I told you, mass of coins, they are relating with what, Hari? Number of coins. So you got, suppose we know that we assumed that 10 grams is equals to 1 rupee coin. Means how many coins here? 1 coin is equals to 10 grams. Now I got 1000 grams. Means totally how many 1 rupees coins I got? All of you.
101 rupees.
Yes or no? So that is what it is. So this bank people, what they will do, they will correlate the total mass of coins with the number of coins. So they can easily, they will be make the denominations, means total amount, by sorting out the weight. So that is why same way it will comes to the atoms and molecules also. Understanding? Atoms and molecules. So tell me, for example, I have given you 1 gram of gold. Now I will ask you to count the atoms. Is it possible to count the atoms? Mr. Harizaras, Mr. Kaushik, is it possible to count the atoms? Suppose I have given you 1 gram of salt. I will ask you to count the atoms. I have given 1 gram of water. I will ask you to count the atoms. Is it possible to count? Yes? Please respond. Is it possible to measure and count the particles? That is what I am asking. Not possible.
No.
Because atoms and molecules are not visible to us. They are extremely small in size. We people cannot count them with the normal, like visible numbers, like 1 to 3. And they are extremely large. So that is why scientists use this concept with atoms and molecules. Same way how the bank employees are using mass relating with the number. Do you understand, everybody? A mass relate the number of coins. Same way, the mass of a given compound, they are relating with the number of atoms and molecules. So that concept only we used to call it as, what concept it is called as? Mole concept. So, molecules and atoms are so small which cannot even seen with the help of powerful microscope. Because what is the size of the atom? I taught you in the chapter. Anybody remember? What is the size of the atom, Harish? Mitaksri? 10 power?
minus
10 power minus 9, what? 10 power minus 9, what?
Nanometer.
Nanometers. Understanding? So it is not possible to see them with even powerful microscopes also. So that is why we cannot measure them, we cannot see them, we cannot count these particles. So to solve this problem, so then how I can say, I have given you 1 gram of sodium chloride, I have given you 1 gram of silver, understanding? So now, how to find number of atoms, number of molecules present in this 1 gram? I will say 0.2 grams of gold. How many particles are present? So, to solve this problem, the new concept what introduced by the scientist, that is only called as, what is that concept, guys? Concept of mole. So this concept of mole was introduced to solve this problem, to identify the number of particles or number of molecules or number of atoms which the given substance is made up of. So that is why this is also we can call it as Avogadro number, or we can say Avogadro constant, because he is the one who has been related this mole concept with this number. So we can say Avogadro number, or also we can say Avogadro's constant. We will say that number also, Avogadro's constant, in the honor of Italian scientist name called as Amedeo Avogadro. What is the scientist name? Amedeo Avogadro. So he is the one with his honor, in the honor of his name, we are calling this mole concept. Also, we can say Avogadro's number, or we will say what? Avogadro constant. Okay. Now, what is this mole concept and what is this Avogadro number? What it is? Let us study that. So, first thing. So, remember, if I will say, suppose now, Mr. Harish Zeras will say that I am having 1 mole of substance. How much you are having, Harish? You are having 1 mole of substance. So I will say I don't know. What do you mean by 1 mole? Sir, is there any particular thing? I will say. Remember, if suppose I will say I am having 1 mole, means in the sense of, remember all of you, the amount of substance, what is that means? The amount of substance which contains 6.022 into 10 power 23 particles. Do you understand, everybody? So imagine that if I will keep 6.022 into 10 power 23 zeros, you might be understand how much big number it is. Suppose these many particles together, suppose I have given you apples or bananas. So these many number of bananas, if I'll keep together, then I will say, which is equals to what, Hari? Which is equals to all of you. How many moles?
1 mole.
1 mole. Do you understand, Emma? So if I'll take 6.022 into 10 power 23. So if you want how the number will come. So 3 days it will become what? 19. Means 6022 and you have to add 19 zeros. 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. So these many number of particles, if we keep together, which is equals to how many moles, guys? Yes, please. Particles, then I will say, which is equals to how many moles? Fastly, everybody. 1 mole
mole.
atoms. Are you clear, all of you? Any doubt? This is only called as Avogadro's number. Understand, Harish, Kaushik, Mitaksri? Imagine how
Yes,
much
sir.
So this number is only called as Avogadro's number, Avogadro's number of a substance. So if we take 1 mole of atoms or 1 mole of molecules, for example, these many gold atoms, if I'll keep gold atoms, then which is equals to how many moles of gold, guys? Everyone should tell me. 1 mole of gold. Is it okay, everybody? Suppose if I'll say these many water molecules, then I'll say which is equals to how many moles of water? You should tell me. How many moles of water? Hurry. 1 mole of,
1 mole.
that is you have to understand. So this is only called as Avogadro's number. So please write it, everybody. Avogadro's number of a substance. You all should learn this. Then from here only I will continue and I will teach you remaining things in our next class. Avogadro's number of the substance. Molecules. See, here I am saying atoms. Here I am saying molecules. Both are same only. Okay. 1 mole of atoms is equals to 1 mole of atoms is equals to how many atoms, Amma? How many atoms? Avogadro number. Which is equals to how much? 6.022 into 10 power 23 atoms. If I'll say particles, particles. If I'll say molecules, molecules. That is you have to remember. Next, 1 mole of molecules. If I'll say 1 mole of molecules, how many particles? How many molecules? 6.022 into 10 power 23 molecules. Are you clear? Everyone? Akilan? Gokul? That is what you have to remember it. Okay. So till here you please learn. Then from here we people will carry on and we'll find it. Okay, guys. So we'll continue from here in the tomorrow's class. With this I will stop. Please learn till here and solve this question once again. What we learn this question. I'll send the PDF also. Then we'll continue from here in the tomorrow's class. Thank you, everybody. Bye. Tomorrow.